Let's read the question here. The diagram below. Regular, hexagon. LMNOPQ, whose size is 8 centimeters. So each side is 8 centimeters. Show that the value of angles P, Q, L is 120 degrees. Okay, but remember the formula I gave you for the polygons? Sorry? And like that's what I was saying, n take away 2 is a hexagon and a pentagon. N take away 2 times 180 good. In this case, what would n represent? Number one? So let's substitute 6 minus 2 times 180 degrees divided by 6. You did this already, by the way? You did this already?
Yeah.
We did one like it, you know, but not this one. Good. So 6 minus 2, guys. Guys, everybody please remember respond. That means to respond with verbally. You have to respond. You say something? Yes. Yeah, okay. Yeah, I know you gotta be funny, eh? Like the last time. 4 times 180. So I do that quickly for me, quickly.
720.
Okay, so 720 degrees divided by 6. 120 degrees. Okay, so see that? This formula, which I gave you a couple classes ago. Absolutely. Come in, I know you can't feed the web, but you can take a picture for it, Erica comes. Because I can't wait for her. Right, so the number of sides go here and here, which gives us 4. Put them on any, so we have just proven that each of these angles, each of them, all of these will be 120. So the value of angle PQL is 120. We just showed it. Somebody go a little further for me now. I don't want to scroll up the screen yet because somebody just reached. And it's, thank you. What is the next question after this? What you got? What's the next question asking? The vertices of a rectangle. PQ, QL, MN, NO. When it cuts them, where does it cut them? The lines. Guys, what do you have in the phone enough? The vertices of a rectangle W, X, Y, Z touch the sides PQ, QL, MN, and NO of the hexagon in part A. Okay, so it's shaped like this. Okay, answer that? ZY. Oh, I didn't put on the letter, sorry. So this is W, X, Y, Z. ZY and WX are parallel to LM and PO. So ZY and WX is parallel to LM and PO. What does parallel mean, guys? Anybody can tell me? But the same direction, but they never meet. They are 90 degrees to each other, and they will never meet. Okay? Calculate the value of angle LWX. 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 So what do? We pull out just those sections. Let me make that as well. W, L, and X. See that? Now, a reason why I left out this extension, because it's not really here. The extension really is not here, but you can extend it if you choose to. The reason why I do it is because when I do it, you could realize what is happening here. What is happening here? Oh, the computer. What is happening here? Guys, what is happening here? You have two parallel lines cut by what? Transversal. The line that cuts a parallel line is called a transversal. You don't have to remember the name, okay? If you don't want to. Now, I'm gonna make this look like over here. Okay? Now, I'm gonna take off that. I'm gonna take off that. Okay? I'm gonna take off that. Now we have just this section here. Okay? Let's say look for the LWX. What you know you have already. There's something that is missing from this. And this diagram over here. There's something that is missing from this diagram that is given over here. It may help you with an angle, yes. It's an angle. I don't right angle, guys. No, come on. So what are you saying then? What angle goes around the hexagon on the inside? 120, we just found that. We just proved that. The question told you that, show that the value of angle PQL is 120. If PQL is 120, that's why I put on all of these others, because all of these are going to be what? All are going to be 120. So look at this diagram up here now, this part here, and look at that. You can clearly see that here will be what? 120 degrees, definitely. Guys, you guys have to open to see these things. We did these recently as well. They said define what? They give back the paper? Yeah. What is it define? So they want to define of here. Right, LWX. The middle letter is where the vertex is. So what is W? So tell me. No, it would be the same. Would not be 90. 60. If it says 60, raise the hand. Who said another angle? Am I saying another angle?
No,
it's 60. Why is it 60?
Because you make the remainder from 180.
Excellent. This and this is what we call interior. Now where is from the keys? Interior angles. Interior angles are what we call supplementary. What is supplementary? Supplementary means adds up to 180 degrees. So if this and this adds up to 180 degrees, if you have 120 already, 120 from 180 gives you 60 degrees. So the angle in here is 60 degrees. You see that? Guys, if you want to bring it just closer, because I have spaces there if you up to you, if your eyes are good. No, we have that age. Yeah. You see that? As I was saying, you have a chance to do both the graphical method, the illustration of the graphical method, or you could do the algebraic method, the mathematical method. We'll do both. Okay? We have negative 310, negative 310. We have 4, negative 4, 4, negative 4. What is negative 310? What's the name? P. This is P, this is what? R. Back check. Okay, so P, R. Let's say do what? Draw a line between the two of them? Or calculate the length of PR. Okay, good. But normally it would be a rectangle. They say something is a rectangle, right? Right? A rectangle would be that this will come down to one here. And this will go up to one here, right? Yeah, but they set up more that though. So you can just pass it. So we have that line go. Not a long ruler, I got a ruler, you know. Oh. Well, here we have it. Is it not accurate? Because the whole didn't go all the way down, okay? You understand? You understand? This is not accurate, so yours got to be more accurate than mine. This has to be quickly. Good, so now, if you do that on a graph paper, if you use a graph paper, you should be able to measure P and R with a regular ruler. Once you have graph paper, the actual graph paper, where each of these lines represent 1 centimeter. You understand? If you don't have a graph paper, you can't measure it with a ruler. Okay? Good. Now, the mathematical way is, what's the formula? Everybody the formula, I think it's an acronym book. There's a formula. We need the full formula. Formula. We need to know the formula. Huh? Oh, yes, good. Okay, good. Look at class. Now, look, as you're drawing that, remember Pythagoras? Remember Pythagoras? Pythagoras theorem. What does Pythagoras theorem teaches us? What does Pythagoras theorem teaches us? If you know the length of what? One side if it's the length of one side, good. If it's the length of one side and the length of another side, you can find the length of the third side. Everybody agree? And Pythagoras, what would you call this side? The red side? The hypotenuse. The formula what? A squared is what? A squared plus B squared. The actual formula is really A squared equals B squared plus C squared. But we put H represent what? Put H represent what, class? The hypotenuse. Now, let's use this. Pretend that each of these represent 1 centimeter. How far down should we go? How far down it is? Eh? How long is this side? We have 2 here is 10, and 2 here is what? 4. So 14. This side here is 14. This side is how much? Let's go. 1, 2, 3, 4, 5, 6, 7. What is 14 squared? 196. What is 7 squared? 49. Okay, I'll carry all this square to make square root now. 196 plus 49. 245. And 245. Square root of that. Somebody please, Shakira, give me that. Shakira, give me the 1 decimal place. Yes, yes. 15.6 correct. 0.6 or 0.5? So 15.6, right? Correct. 2, 1. This is one please. It does. Everybody see that? Everybody see this? So what did I do? Oh, sorry, down here was what? Sorry, I didn't write it. Down here was what? But it's saying it. Down here was what? Good. So if you do the length of 2 sides, you can find the third side based on Pythagoras' theorem. Everybody see that? Good. Find the square of 14, 196 is square of 7, 49, you add them up, you square root to 45. Where did the square root side come from? Anybody tell me? Where did the square root side come from? From the square. When the square cross the equal sign, it comes the opposite. Okay? That's where it comes from. Here, up to the thing here. Okay? So 15.6 based on what Shakira says. Now there's another method you could use. Remember, as I said, you could have, if you have graph paper like Bantif, something Bantif. If you have graph paper like Bantif, like this, you can actually take a ruler and measure it against 15.7. Why? Where's the biggest paper? 15.7. It's a breaker because we're starting from 7. But I don't know. But I don't know what kind of measurement that. Right, you see? Anybody want to come and peek? Inches. Good. See, 15.7. You see that? But see, if you come and see, you will realize the ruler measures 15.7 or 0.6. What would they? You'll be, what would they say? They'll say it won't kill you for being off by a little bit. Thank you. Thank you. Good, good. But understand? What I'm saying to you, in exam, if you want to calculate all of this, you could simply do this, connect there to there. You know that the left side, what triangle has to be formed? You tell me. A right angle triangle has to be formed, and that's the easiest thing to do. And the fact, you cannot go this way now. And how do you know how to form a rectangle triangle? Because it said something in the question that you're forming a rectangle. And each corner of a rectangle forms what? 90 degrees. All those are dead giveaways, okay? So you have the construction you could do, which I prefer. Once you could draw fast, and these coordinates are very small. And then there's this way. But you have to remember this formula here. So the formula here, you will see it in some books look like this. Remember on the screen. You can see it like this sometimes. So they carry out the square root sign one time. You carry out the square root sign and you see A equals the square root of B, square root over B squared plus C squared. Okay? Take a picture of that. Let's try something now, the mathematical. You guys can see the dark area here? Yeah. So if I want you the dark area there, I can see. So I was trying to fence with this to right. Okay. And I'll clean the board. Might have it? I'll clean the board now or get it a little more time. Wait. Okay. Dominique will give me x2 minus x1 squared. Dominique will give me x2 take away x1. What's the name, sis? Pashi, what is your name? Taylor. X2, X1. Huh? X2, 4. Excellent. Dominique, back to you. Y2, take away Y1. Six. No.
Points.
Dominique. Y2, take away Y1. Then listen. Negative 4, take away 10. Elson, 4 take away negative 3. Yeah. Huh? No? 7, sir. 7 squared. There we are 9. Negative 4 take away 10. Make that thing in your hand, eh? Make the thing in your hand. And you put on the wheel and bring it down. Okay? Somebody else go. Continue. Come in. Yes. Yeah, give me the working. 49.
Minus 96.
That minus.
No,
A negative and a negative class. Except square. So you multiply it by itself. So it'll be positive. 196. This ain't look familiar, guy? You just do it, you know? I guess why you get them students in school all the time. That's the one. Being got to work hard to see somebody pay attention. Being got to work hard to see somebody pay attention. You could tell somebody to pay attention. Because we're working back all the same questions and people say them a gum tree. What age is? 16? 0.7?
Yeah, because after it's 15.65.
Or 6.1?
Yeah.
Also 15.7 then?
Yeah.
Correct. 2, 1 decimal place. It was significant figures. How much significant figures is that? That is 3. That's 3 significant figures there. Okay? So another way, instead of doing 1 decimal place all the time, so we might just say it's correct to 3 significant figures. Okay? Pass it, camera. But I want to grab the camera now. And then before my one, would it? Correct you. Alright, so y-intercept, this is the x coordinate, this is what? The y coordinate. So those coordinates that were given before, call the coordinates that were given before. -3, 10, or 4, -4. Good. So this negative, if you use this point, which we call this point again, they have name. This is what P, this was P, this was what? Q? R. If you use it R, based on this formula, what will go here? Good. Now what will go here? See now 4, -4. That's it? Good. Those coordinates. If you use this, -3 goes here, and 10 goes where the y is. You understand? This is x, this is y. Good. So determine the equation of the line PR. This is the equation of the line. Now we have 2 things. You have 2 points given to you. Any one of them can be chosen. Choose the one that works best for you. People don't like to work with negatives. But both of them are negatives, so you solve. So then, I prefer the y to be positive. So I will choose this. You understand? I want the subject to be positive. Now you got less problem when your subject is positive. You don't have to follow that rule. You can use anyone you want. You understand? And that's making it easier for you to do, you make less mistakes. Right. Now, the first thing you look for, first thing you always look for, wait me somewhere. When you get this, the first thing you look for is the gradient. The gradient has a formula. It's a small m. Small m. Rise over run. In other words, how high are you going while walking across? So this is steeper than this. They're both going that direction and up. But this one here is steeper. You understand? This one is more gentle. You understand? Good. Going on Grimstone Hill, that is what? Steep. That road out here is gentle compared to Grimstone Hill. But both going along while going up. Okay? So it has a run, which is a distance, and a rise, which is an elevation. Okay? The rise and the run clearly on an axis. Which axis will represent the rise? The y. So you put y2 take away y1, and the run will be what? x2 minus x1. Again, we have to go back and put back labels on these. We could use the original ones we have. x1, x2, y1, y2. You see that? Again, remember, we learned something for the first day. People who have never seen this before, go home and research. Go home and research. Go home and research. Okay? Let's go. Substitute for me now. Yes, sir. Naval. Why to take away y1? Quickly, let's go. -4, take away 10. see, good. Kelsey, X2 take away X1. 4 take away -3, my friend. That's -3, okay? Candace, top. Erica, bottom. No pun intended. Look one again.
-4 minus this, that's 14.
No.
Minus 14, sorry.
God bless you, so.
Okay, I had to come up with
Yeah. I know that's what you're doing, fix it. I know you know better. Here we go. 7. What's the gradient, Calange? Yes, sir. -2. That's an easy one to give. You get nice gradient. You get nice little number. So we go back to this now. Go back and write down this, that clean half now. We're going back to this. We now have something now. We have y, we have a gradient, we have x plus c. We're building out our formula. The next step is to find the y intercept. To find the y-intercept now, who can tell me? Help me out. Somebody look at how I'm doing. Remember I told you about these points? Can these points be substituted? Yeah. So substitute, what does that mean? Substitute or substitution. You can use any of the points. Which one is I prefer to use? I'm not the one outside positive here. So let's go. So y can be what? 10 and x can be what? Good. So 10 equals 6 plus c. How do I get c? Let's go. Tell me, let's go.
C equals C.
So what do you think c is? 4. So we find two things now. We found out that m is -2, and we now found that c is 4. Okay? But to complete now, you have to make it back empty. Because we don't want any individual points. Because remember I said earlier, any point can be used. And a line got thousands and millions of points. So you don't want the points. What you simply do, you put back the y, you put the gradient, you put back the x, and you give me the y-intercept, and you finish. That is the equation of the line. So what you're saying, any point to substitute now, you can use -310, you can use 4 -4, you can use something else that you want based on the line. But the equation of the line must have a gradient, you have to find the gradient, then you have to find the what? Y-intercept. In our case, the y-intercept is what? C. I've seen in some textbook that have plus B. It's irrelevant, it's just a random letter. But in saying it's in CXC, you tend to see them as textbooks that use CXC, you tend to see them y equals mx plus c. But the American books, which I have looked through, you see y equals mx plus b. Okay? Don't let it betray you off. It's still that last number behind here is the what? Y-intercept. Don't finish. Can we backtrack? Where did -3 and 10 come from? Coordinates of R. Of P. Of P, sorry, P. But can R be substituted? Yes. Good. How do you find the gradient? Good. Here you now. Go back to your graph paper. You took down that already. Yeah, you got one now.
Will you put me?
I'm not going to see.
No, in your arm.
Oh. Everybody see this? Y is over 1, 40 divided by 7, that's what the camera could be. So it's a negative slope, positive slope, hence Shaman minus 2. The minus side of the 2. Okay? This is a positive relationship, this is a negative relationship. Stop it. Alright, good day everyone, good day. We're dealing with January 2023. January 2023. Question 3. Okay? Question says we have 3 quadrilaterals. I don't know if you see. We have P, we have R, we have Q. Okay? The first question says draw the image of quadrilateral P after a translation by the vector 10, negative 4. Looking at this, we all know what translation means. Another word for translation. Give me some synonyms. Huh? To shift. You're shifting it from one position to another position. Another word would be with M. Movement. Move it. Movement. Do you understand? So again, translation simply means to shift or to move a point, a line, or a shape. The 3 things you can move. A point, a line, and a shape. But guess what? In this quadrilateral means it has how much sides? 4 sides. In this quadrilateral, it has 4 points. Well, 4 vertices, within it has points as well. But 4 vertices, 4 sides, which is 9 segments, and then the whole shape is a quadrilateral. We're going to shift the whole thing 10 places to the what? To the right, and 4 down. Very good. Because positive means right, and negative on the y-axis means down. Okay? So let's shift all the different points. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. To me, you're going to do that there because I can see the shape already. You catch? This other point will be what? Here, right? Yeah. From common sense, you realize it's going to be here because you're going to shape like a triangle. You see that? If you still want to count, you can still count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And what about this? Should I write 10 again, go class? Give me the... No, we don't have to do it. Look at this and you can tell the shape. What's the shape? Where would this land over there? Give me the coordinates. It's very easy to see. I need everybody to pay attention.
3, 4.
Look again. Give me what? 3 up 4. Very good. See that? And that's the back check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 2 ways you could do it. You could count all of them. You could count all of them. Or when you find one and you get a general shape is being formed, then you use it, you just save time in exam to fill in the others. Not all shapes are easy like this. Some other shapes are not going to be that easy. You do have to count still. Now when you only went 10 across, the next instruction is to what to what? Everybody? Go down 4. Good. Let's go down 4. Let's choose this point. Let's go down 4 this point. 1, 2, 3, 4. That's the bottom part, okay? Let's go down 4. 1, 2, 3, 4. Okay, good. Can somebody help me do this? The coordinates before the next one be. If this is one away, this is just one box. These are the same box. And in different corners of the same box. What do you think this will be? 3, 3. Very good. Everybody see that? You realize this and this is on the same box? Yeah. So it will be the same box. Good. So When the next one, yeah, look at you be quiet. When the next one gonna be? I'll show you go there. When the next one gonna be? Besides Erica, two. Very good. Awesome. So you got a shape now. This is the final shape you're supposed to have. So it shifted here first, then it went down. It went past 10 and it went down 4.
It's supposed to be one shape, right?
We're supposed to be one shape, yeah. But I just do two just to see to show you guys. You don't you don't have to want me to. If you leave it if you want to, it wouldn't be it wasn't a distraction here. Those who are using those printed material. Oh, that's reading that. Okay, so this is now called what? P what? Prime? P double prime. Remember see that? So this has been shifted from here to here and from here to here. That question now is answered. It said, do a reflection in the line y equals 0. No, this is not double prime. This is just prime, right?
Yeah.
My bad. I get mixed up a bit. Right, good, sorry. Now, who can tell me where the line y equals 0 is? Huh?
Could you repeat the question?
Tell me where is y equals 0? The x-axis. Excellent. Remember, y is the horizontal line because they follow the numbering. What the numbering? The numbering is increasing going where? Up, right? Those numbers represent the y on the x-axis. So when y don't be 0 here, the x-axis is actually y is equal 0. So where y is 4, will be here. That line is y equals 4. Imagine that? Where y is negative 6 will be here. Y equals what? Negative 6. Imagine that? Imagine that?
Yes.
We will switch it wrong. Where x will be 5. What line will be x is 5? No, let me say x negative 5. Let's say negative 5. Oh, they don't cut it already. X is negative 5. X is negative 5 will be what? This line here. Imagine that? This line is x equals. Yeah, see that? This line is x equals negative 5. Imagine that? So remember, the x-axis, the x equals whatever number line 1 vertical. And y equals whatever number line 1 what? Horizontal. It feels kind of odd, but that's what it is, okay? Good. So we're going to reflect over this line here. The x-axis as Lisa said. Okay? I can remove these now. Remove these now. But because we're going to use the same graph. We have the same graph. Let me take a picture.
Beautiful, mate.
Yeah. Okay.
Thank you. Yeah, nice.
Yeah. Okay, good. So reflection in the line, y equals 0. See here, y equals 0 is here. We don't have it on both sides. Good. What is a reflection? What does reflection require you to do? I gave you some properties to see a reflection.
One side.
You have to find a mirror line. Oh, yeah, come in. Wait. You find the mirror line. The mirror line will be this, obviously. You see that? Can't see that one. But x-axis will be the mirror line. Go ahead, Sanya. Sanya, see what you're saying?
But maybe one side and one other.
Yeah, but it's still missing something. You're going good, but it's missing something. Think about distance.
Same distance. Probably.
Let's give these some random letters. A, B, C, D. That's how I get things done. The mirror line is the x-axis, okay? How far is C from the mirror line, which is the line of symmetry? How far is C?
4.
You count it, what, 4? 1, 2, 3, 4. So then you have to count 4 on the other side. 1, 2, 3, 4. So now that comes here now your new C. You must see that?
Yes.
How far is B from the mirror line?
6.
Good. 1, 2, 3, 4, 5, 6. So count down 6. 1, 2, 3, 4, 5, 6. From here, I think you'll be able to, you should be able to form your shape. But let's go. How far A is from the mirror line? 7. Very good. I'm not going to put more red lines because you kind of making the board look cluttered. So you know it's 1, 2, 3, 4, 5, 6, 7. Count 7 as go down. 1, count with me. 1, 2, 3, 4, 5, 6. And if you are at incline, if you could draw, you could finish off this now. Where the other coordinate go? Somebody tell me where the other coordinate will go. Give me coordinates.
8. 8. 5.
And 8.
Negative 8. Negative 6.
Negative 8.
Negative 6.
Negative 6. And you're going to look upside
Down.
down now. So what do we learn about reflection? The same distance, you can take out this C now, because that was just helping us. Those were just helping us to keep what? In line, okay?
Yes.
Good. But when you're done, you can take them off. You can leave them if you want to. This now becomes P double prime. Okay? P double prime. Remember that? Good. So it's like you flip over, like a book flipping over, back. You don't do that? You don't do that? But let's go, guys. So we did it graphically. We did it with an illustration, which I'm teaching you guys in exams. I think doing things on the graph will be easier for you because you want to see things. But those were more algebraic in thinking. Those who use like numbers and letters. What is the formula for translation? What's the formula for translation? They're taking all day with this. Let's go. What's the formula? I gave you the formula.
T plus P.
T plus P.
P prime.
Can it be P plus T? Yes, because it's what? Commutative. So sometimes somebody might get the P for the T, the T for the P, don't let that throw you off. The T stands for what? Who could tell me? Translation. Or it could be transformation too, but which transformation we dealing with? Translation. Everybody understand?
Yeah.
Good. And then P and P prime. Now I'm going to show you something. Because it's addition, both matrices must be the same. Now, what's the translation again? 10, negative 4? Write it 4 times. 10, negative 4, 10, negative 4, 10, negative 4, 10, -4. Why did I write this 4 times? You could tell me.
4 points.
4 vertices, very good, 4 points. 4 edges, 4 vertices. Good. Now, what are the vertices? I'm gonna call on individual people. Ms. Huggins, what is this vertex? Carl, give me the coordinates. This one. You can start from here, come up.
Teacher just said you are putting the oil.
Okay, then listen. Give me this one, then listen. You have paper for the year, you can use the one for the year. Huh? Look good. The -8 is here. Huh? -7. -7, 7, good. Dorisio, give me this one. -6 and 6. I'm not checking for me, please, because them gave me trouble too. I'm not going to see a problem.
I know he said I should take a class and we said,
What is one is now? Somebody, anybody?
-7, 4.
-7, 4, and the last one.
8, 6.
Good. Kalanji. 10 take away 7. 10 take away 7, yes? Huh? You're falling back behind. 7 take away 4. 7 take away 4, sir. 7 take away 4. Somebody help me.
3.
You might somewhere else, man. You might want your chicken home or something, man.
You put 4. You put 4.
Huh?
Yes,
I know.
so what you want now? I know what I do.
I chicken it. Ada. 10 take away 6. Ada. Huh? 4. Ada. 6 take away 4. 6 take away 4. Everybody help me. Everybody start for you, no? You go to class, say, Ada. 2. Val. Then 10 take away 7. 4 take away 4. I get all the vowels in here. And Shabari, 10 take away 8. And 6 take away 4. Let's verify our points now. What do you call this? 2? 2, everybody see that? Then let's look over there a little bit. 2, 2, see that? See that one gone? We have what? What do you call this?
3, 4.
No, look.
No, 3.
3. So this one gone. What do you call this one? Oh, that's 3, 3. What, sorry. What do you call this one? No, don't do that. So what do you call this one?
3, 0.
3, 0. The last one is what? 4, 2. Everybody see that? Anyone try this in exams? But how quick and easy this is. You just gotta wait for 10, 10, 10, 10, 10. Minus 4, minus 4, minus 4, minus 4, minus. If it's a pentagon, then you have to write this over times. 5. If it's a hexagon, how much of these you have to write? 6. You catch me now? So don't limit yourself to 4. If it's a triangle, there's only 3 you're going to use. Okay? Remember that. And these are the points of the quadrilateral. That's why we have 4 of them. Okay? And then that's the result. So if you can't draw and the paper hurting your eyes, Miss Huggins, then this is the way to go. Okay? And what's the formula now? What's the formula for any other transformation? Who could tell me?
TP
TP equals, it could be P double prime. But this is P double prime. I'm gonna give you this now. I'm gonna tell you something. This is the reflection. This is the reflection matrix for 2 by 2, a 2 by 2 matrix. 1, 0, 0, negative 1. This is the reflection over the y-axis equals 0. Now these are very hard to remember. I don't try to remember them neither. But I'm gonna still show you how to use it if you could remember them. I don't remember them. I have never tried to remember them and made a kid to remember them. Right? But this is the matrix for reflection. Reflection over what? Y equals 0. And it's a 2 by 2 matrix. Okay, you can see? Alright? Everybody understand? I guess you can try to memorize it because CXC technically the easy ones. They either tell you reflect over the x-axis, which is y equals 0, or reflect over the y-axis. And the y-axis will be what? If the x-axis is y equals 0, what do you think the y-axis will be? X equal what? 0. It makes sense what? Negative 2, negative 1, x is what here? 0. 1, 2, 3, 4, okay? Ain't take much thinking, guys. You just got to orient yourself that way, okay? So that's the matrix. If you want to memorize it, that's you. Now, the fact that this is a 2 by 2, and this is multiplication, what has to happen over here? Who could tell me? It could be a 2 by 2, but we have a problem. We have how much coordinates? 4. So you don't have to be a 2 by 2.
2 by 4.
It could be a 2 by 4. Thank you, Erica. Because all that has to match up is what? The rows for the first and the column for the first and the row of the second must match. And what the result will be? Who tell me? A 2 by 4. Everybody see that? So give me the points for P. We have them over here already, so don't bust it with the thing.
Negative 7 and
Negative 7, 7,
negative 6, 6,
negative 6, 6,
negative 7, 4,
negative 7, 4,
negative 8, 6.
negative 8, 6. Let's do some working out now. We're ready, guys, I'll change the color, okay? Let me see the next one. Okay. Oh man, this got some juice in it, man. Let's go. Remember what we do row, column. Okay? Remember row with column. Somebody sort me out. Papa. Let's go. 1 times.
Negative 7.
Good. 0 times 7 is 0. Let's make that be bigger, man. 1 times negative 6. They're going to be what?
0.
So if you bunch of 0, you see the pattern? So it's going to be what? Negative 7 plus 0 and negative 8 plus 0. That's easy to see. Look at this one now. 0, negative 7 are moving quick, man. Nice. 0, good. So continue. 0, negative 4, 0 and let's see what we get now. Negative 7, negative 7. And negative 7 here? This is negative, this is negative 7. Negative 7, yeah, this is negative 7, negative 7. Okay? It's negative 6, negative 6, negative 7, negative 4, negative 8, negative 6. I don't know if I could recommend this method, because as I said before, I don't know if I can remember what this is. They don't give you in the formula sheet, These are things you got to try and memorize. You go in the exam to set them over your head and set them over and over your head. I won't waste time with that. I want to simply reflection is very easy. The same distance it is on the mirror line, in the mirror, it's supposed to be the same distance, okay? But I still sure that it can be done based on matrices, okay? That's all I'm trying to show you. It could be done based on matrices still. Read the question again? Yeah, everyone read the question?
Describe fully a single transformation that maps quadrilateral P onto quadrilateral Q.
Well, draw up a transformation that maps P onto Q. Anybody can think of anything? What are the four transformations you know? We did two just now. Give me the two. Translation, that means what? Move or shift. Next one was what?
Reflection.
Reflection needs to be over what? A mirror line, which is the line of symmetry. Okay? What are the other two? To help you? Rotation. That look like a rotation to you?
And enlargement.
No. That look like a rotation, but the other one is what? Enlargement. There's an opposite word for enlargement. Shrinkage. I see some books put dilation instead of shrinkage. Okay? It means the same thing. Your eye is dilating, or the woman is dilating. Okay. We just take those examples. We are big people here. They're not going to abandon us. That's going to happen. But it's a dilation. Okay. So clearly it's not what? Rotation. It can't be translation because it became what? Bigger. Can't be reflection because it became bigger. The only one that could make it bigger is enlargement. It could be the opposite way. Q became shrink to P, or P was enlarged to what? Q. Can you match point to point? If I do this, look at this point here. Where would be the corresponding point to it? Where would give me the coordinate of the corresponding point to that? It looks like a kite. And you make the kite, this is an image of the kite, and you make the kite bigger. Where would that Q match that position? You're close, but you say wrong. -1, 7. These two match. Let's use the letters to see. Let's call that A, that will be what? A prime. Okay? You understand? This will be what? If this is B, where will be B? And the other one? -4, 4. I want one minute. If this is C, 2, 4. And this is D. No waste the time. That's about that. Yeah. Take a ruler, right? Now, watch how much take a ruler.
Take a ruler.
And draw a line right off the page. Right off the page. Let's draw it right off the page. Okay? Hey, come on. Okay, good. Take your ruler and draw from B prime to B. You see that? Draw it till you go off the paper. Enjoy anything now, man. Draw it till you go off the paper. Hold on. Ruler ain't long enough. Just by those two alone, you should see something. Am I see something? Just by those two alone, you see something. Where you see? Give me a word. No, me not want to triangle though. Go try it. Check.
Triangle.
I said not a triangle. I see that none of them listening. What? What's happening here again? Watch. What is happening here? What is happening? No, these are the reflection. We don't establish this enlargement, so don't bring back up the reflection to the translation, guys. We go from C to C. Guys, alright, so something convergent. That word converge is a big word to you. What does converge mean? Huh? Yeah. Repeat the words that you said that. Good. So what word do you use in geometry? I realize something. All the lines are not what? Intersecting. But you see that? All of the lines, when you draw them, they are what? Intersecting. Where are they intersecting? Where are they meeting then? Thank you. Negative 10, negative 10, 7. That is now considered the point of enlargement. This is the point or center of enlargement, sorry. Center of enlargement. Okay? That is seen as the center of enlargement. So how do you find the center of enlargement? What you do, you match point with point, take out the B now, and the B and the A. Those are things that we just make up. Just to keep us in check. When you match up the corresponding points, and you draw a line from each of them. If you realize something now, one has stop waiting for me. One has stop waiting for me. How much boxes will come from here? Let's go. Give me the blanket. 1, 2, that's 3, right? That's 3, right?
Yes.
And from this point to the corresponding point is how much? 1, 2, 3, 4, 5, 6. What would you say about that? And from here to here is how much? From here to here is how much? 1. And from here to here is 1. But from here to here is 3. That's not the same corresponding side. Everybody see that?
Yeah.
That means this is what? This is what? Triple this. Okay? You see? 1. Okay. So, okay, that double, sorry, I made a mistake, it's not double. It's supposed to be triple. Okay, because then, how to fix this? 1, 2, 3. So what's the full distance now?
9.
The full distance is 9. Okay? It is 6 more. But from here to here is 9, and from here to here is 3. That means it was what? 3 times 3. 3 times 3 is what?
9.
9. So it's actually triple. That means it's not going to be a half. It's going to be what? A third. Am I see that now? So the distance from here to here is 1. From here to here is 3. From the same distance. You have to all be from the same point. Okay? Let's see something else. Let's look at the inside of the triangle, inside of the diamond or the kite. How much boxes did the kite cover? 1, 2, 3. How much this one cover? 1, 2, 3, 4, 5, 6, 7, 8, 9. Ever see that? So we established it. I made a mistake earlier. It's not double, it's actually triple. Good. So when you're dealing with these, so when you're dealing with enlargement, everybody write this with me, please. You're dealing with enlargement. One, you need to know center of origin. What's the center of origin? What's the center of origin? Negative 10, 7. And then you need to know the scale factor. That's the word I was looking for there. Scale factor. What's the scale factor? What's the scale factor? Yeah, what's somebody saying to so? 3, 9. 3, 9. It was once 3, it's now what? 9. What's the scale factor? I taped something, we got it. 3 times. What's that? Good. So, 3 things we mentioned. It's enlargement. The enlargement is through the center of origin this, and the scale factor is that it magnified it 3 times. So you get to look it up. Yes, guys. Just match another point. I would advise match this with this. It could be any other point, but match this with this so they don't cross each other. Okay? So top with top, bottom with bottom. That's what we know, guys. Okay? Now, when you're done with that, you guys remember how to make a perpendicular bisector? You're gonna make a perpendicular bisector. We did it Tuesday. You're gonna open your compass. Somebody watching? You're gonna open your compass to more than half. This is a line segment. You're gonna open your compass to more than half, and you're gonna draw an arc here and an arc below. Then you're going to take this compass, don't let it go in, keep it the same distance, go over here, and back. Then you're going to connect those. So I'll advise you, maybe use a pen or something to get a different color, because you start to look cluttered there. Right? You want to do a bisector, so you're going to bisect both those lines. I don't have to bisect here. Okay? So you're going to bisect both of those lines. If I bisect this, back with back, and then I come over here, back with back.
Is there the polar, you know?
Huh?
The polars?
We use a different color. I tried. Okay, imagine that, I use a different color. Then I'm going to bisect this other line. Okay? Wait, this line is supposed to go further. Draw this line as long as possible. Then you bisect this line here. Boom, and done now. Am I done draw the line? Bisect those two. Bisect that line, back. Draw the other line, bottom with bottom. Then you bisect that line. And when the two bisectors touch, the two bisectors are supposed to touch at -4, 2. They're supposed to touch somewhere there. So this line is supposed to go this way. Okay? If I say that?
Okay, wait. I'm getting it.
And then this bisector is supposed to go and touch here. Everybody see that?
No, sir. I'm taking it.
Dapat ikaw.